this. But the idea is you got this like steel tube.
Okay.
The people stand on the edge of it. They're like inside it, you know?
Mm-hmm.
And it starts to spin. So their back's against the wall and it starts to spin and they are pushed up against the wall. And then the floor drops out below.
Mm-hmm.
So basically the idea is the friction is holding them against the wall so that they don't slide down with the floor.
Okay.
So there's no seat belts or anything, it's just friction that holds them there.
Okay.
So this tube is just spinning. It needs to be spinning at certain speeds so that they don't slide down the wall.
Okay.
And it says it's 5 meter diameter static coefficient of friction. So the minimum mass is 30 kilograms. Because that's what it says. There's a sign that says you can't have children that size. This is 5 meters.
Okay.
And then it gives you 2 or 4 coefficients of friction actually. So which one do you want to use?
Let's see. Clothing has a static coefficient of friction against the steel in the range 0.6321, and kinetic coefficient in the range 0.4 to 0.7. Kinetic coefficient. But we want the static
Right.
friction.
And which one do we want to use of the 2 that it gives us?
0.63.
Yeah. Because that'll give us the minimum that it's safe.
Okay.
Because like, if you use 0.63 in your calculations, if someone comes in and they have clothing that's right at 0.63, then they're still not going to slide. But if you use like 0.85 or if you use 1, and you plan for it that way, and then somebody came in with clothes that were a little bit slipperier,
Mm-hmm.
then they would slide while everyone else wouldn't. So we'll use this one, okay?
Okay.
And then it says what's the minimum angular speed
Yes.
in what units?
RPMs.
Okay, for it to be safe. So if you take one of these people, what are the forces acting on them?
Well, gravity.
Okay,
And then, I don't know what you, static friction,
yeah, so which direction would static friction point?
the
Let's say,
direction it's rotating.
let's say the wall is right here. Kind of up against the wall right here.
Okay.
Yeah, it does push them along the outside of the wall. But that's not quite as much as what we're worried about.
Okay, so we're points towards the center?
Well, we're worried about them sliding down, right?
Yeah.
So the friction that we're concerned about is this one.
Okay. Okay, yeah.
It's kind of holding them in place on the wall.
Alright.
So this would be static friction. And then, what force is going this way?
Centrifugal?
It causes a centripetal acceleration.
I really don't understand that, I don't think. It's centrifugal, but I don't know.
So centrifugal is it's an imaginary force.
Yeah.
You'll never, as far as physics, you'll never use it. It'll never be the answer to really anything unless you're talking about imaginary forces. But centripetal means towards the center.
Okay.
So there's a centripetal acceleration, and it's just a piece of acceleration. So acceleration is a change in velocity or direction, right? So change in speed or direction. So if you're going along at this speed and you turn this direction, that's an acceleration, right?
Mm-hmm.
So you're accelerated in that direction. So if you're going around in a circle, what's always happening?
You're always accelerating towards the center.
Right. Even if you're going at the same speed, a constant speed, you're always accelerating towards the center. So that's what centripetal acceleration is.
Okay. Centripetal.
Yeah, centripetal.
Okay.
So there'll always be, because force equals mass times acceleration, in order for there to be an acceleration, there has to be a force pushing it towards the center.
Okay.
So what is it that pushes these people, that keeps them going in a circle rather than just shooting off?
The steel?
Yeah, the wall that they're up against.
Yeah.
So that, we'll just call that a normal force.
Okay.
So in this case, the normal force goes this way rather than being up or down.
Okay.
Alright, so,
the normal force points towards the center?
yep.
Okay.
So in order for it to be safe, static friction has to be as large as gravity, right?
Mm-hmm.
Yeah.
So 9.8. 1.
Well, static friction minus force of gravity has to be 0. So static friction minus mass times 9.8.
Okay. Okay, and the minimum is 30 kilograms for mass?
Right. We'll leave n in there for now.
Okay.
So then what do we do about, so this is your sum of forces in y. So then you sum your forces in the r direction, so towards the center of the circle.
Okay.
And that's just going to be your normal force. That's equal to mass times velocity squared over r.
Okay. I got this written wrong then. So that's centripetal force.
Yeah. And there can be different things that contribute to it. It could be tension, or it could be normal force, or it could be friction.
Okay.
A bunch of different stuff. But so in order for this to be safe, what does static friction have to be?
Is equal to the force of gravity times mass.
Okay. And then static friction is actually just our coefficient of friction, so 0.63 times our normal force.
Okay.
So what does normal force have to be for it to be safe?
Let's see, mass times gravity divided by 0.63.
Yep. Okay. Normal force has to equal 9.8, or yeah, 9.8 divided by 0.63. What is that?
By 6, 3. 15.5. Or 15.6, I guess.
So normal force has to be 15.6 for it to be safe. We put that here. 15.6, oh, 15.6 n, sorry. N is equal to mv squared over r.
Okay.
So now you solve for your minimum velocity. This is 5 meters. What happens to m?
Cancel out.
Yeah. So actually their minimum mass doesn't matter.
Okay.
This route will work for anybody, no matter how much they weigh.
Okay. So, we take the square root of 15.6?
Well, you multiply it by 5 first.
Oh, okay, right. So, okay, 8.82.
Alright, so this is your minimum velocity. It's in meters per second.
Okay, and then we're trying to find angular speed.
Right.
So we divide, let's see, we just did this. The so we just divide it by the radius.
Right. So 8.82 over 5.
1.67, excuse me, 1.77.
1.77. That's your omega in radians per second.
Okay, so we gotta get it in rotations per minute?
Yep.
Okay. So we times it by 60.
Yep.
And divide it by 2 pi.
Yep.
$16.84.
Yeah. That's good to me. Oh, so it's incorrect.
Yeah, I didn't like that one.
Shoot. Hmm.
Did I?
So our,
Do I need to times that by 180 over pi?
no, that's, because it's already in radians. You don't use degrees at all for this one. So let's see. Static friction minus the force of gravity. 0.63 times the normal force. Plus that.
I know what it is. It's 2.5 is our radius.
Oh, yep, sure enough. So 15.6 times 2.5. Square root of that. So our velocity is 6.24. And then there we go. 6.24 divided by 2.5.
Okay, so we're 2.496, 2.5, so.
Yeah, so 2.5, you can take it through that.
Okay, so. Okay, 23.84.
Alright. 3.9. I got just a little bit more than that, so.
Okay. Boom.
Sweet.
All right. Well, I think that about wraps it up. I need to use the bathroom, so.
Cool. Sounds good.